We've all heard about laser processing. Why should OEMs consider these systems when designing and building automated processing equipment?
Laser processing is becoming more and more popular in the packaging and converting industry. One major trend driving the adoption of laser processing systems is the digital printing revolution, which has made short production runs a much more attractive and economically viable option. Brands can now apply a high degree of customization to packaging to help their products stand out on the shelf or to appeal to a targeted market segment. The next logical step is a digital post-processing solution to replace mechanical dies and other analog tools, which must be ordered days in advance and are limited to a single job. Enter the CO2 laser. When coupled with a proper beam delivery system, a CO2 laser enables a fully digital processing solution for packaging applications. Cut patterns can now be controlled via software and can even be changed on the fly without the need for any tool changeover. This is the power of a digital processing solution. In addition to flexibility, some of the other benefits of a CO2 laser system are reduced operating costs by elimination of consumables such as mechanical cutting blades, dies, and inks, not to mention the storage space required for the associated materials, and sensitive material processing. Only the laser comes into contact with the target material, so you can avoid some of the issues associated with mechanical systems like snagging, binding, and indentation or pressure marks.
Let's watch a short Synrad video that demonstrates one aspect of laser processing: KISS cutting adhesive labels.
Synrad high-performance CO2 lasers are an excellent tool for use in many packaging, converting, and labeling applications, especially when precision and flexibility are required. A Synrad CO2 laser enables a truly digital converting solution to maximize productivity for short-run and quick changeover jobs. Job files can be modified on the fly with little to no downtime, and no need to store mechanical tools and dies. Here, the laser parameters were carefully optimized to cut the top layer material without scoring the liner underneath.
What type of automated processes will a laser perform?
When properly designed, a CO2 laser system can be a very powerful and flexible tool that can perform many jobs, sometimes in the same setup. Some examples of processes where CO2 lasers really excel are permanent marking and coding, including barcodes, expiration dates, text and graphic symbols, cutting, perforating, scoring, and even ablation or material removal.
CO2 lasers have been around for a while. How does it compare to fiber and some of the other laser types?
Selecting the proper laser type is a very important step in the development of a laser processing solution. One of the defining aspects of a laser is the wavelength of the light it emits. The wavelength of CO2 lasers is around 10 microns, while fiber lasers are typically closer to 1 micron. This is important because all materials have a characteristic absorption pattern which varies with the wavelength of light. Typically, the higher the absorption, the better the process results. Due to this, the 10 micron wavelength of CO2 lasers is superior for most organic materials, including plastics, wood, thin films, and paper. In fact, CO2 lasers have been the workhorse of the industrial laser processing world for over 30 years, starting around 1985 when Synrad shipped its first laser.
How can an OEM determine the best laser for their application and system?
As I mentioned previously, selecting the proper laser source for your process is critical to the success of the job. Once a CO2 laser has been identified as the best choice, there are several other parameters which must be optimized, including average power level, peak power, operating frequency, and specific wavelength around 10 microns. To help guide our customers through this process, Synrad has established global application centers in the US, China, and Germany. After we receive a material sample, we work closely with the customer to understand their needs for throughput, speed, and process quality. We then use the latest technology to test the material and identify the optimal laser source and beam delivery solution, all free of charge. The final application test report includes laser processed samples using the customer-supplied material, a listing of the recommended equipment, and specific process parameters.
We would like to thank Jesse Wei, Senior Product Line Manager at Synrad, for answering our questions today. For more information about high-performance CO2 lasers, visit synrad.com.